All right. Okay, so we have already talked about translations, our slides moving left and right, up and down. We've done our reflections. The only one last thing we have to talk about is stretches and shrinks. And just like translations, where we can translate vertically, up and down, or we can translate horizontally, left and right, stretches and shrinks are the same way. We can vertically stretch or shrink. That means pull it up and pull it down, or push it up and push it down, okay? Or we can do it horizontally, stretching left and right, okay? So let's talk about those two. So first, let's talk about a vertical stretch or shrink. So this is when we stretch or shrink it up or down, up and down. So we pull it up and pull it down. So vertical, since we're pulling it up and down, we're actually going to be pulling it away or towards the x-axis. Okay, so that's what's going to change, is its distance from that x-axis. So it's going to be pulled away or towards that x-axis. So let's go ahead and let's look at our parent. Okay. All right, so let's go ahead and let's do our traditional parent that we've been dealing with, that f of x equals x. Okay. So I can stretch or shrink this guy either away or towards the x-axis. Again, remembering this guy here is our x-axis. Okay, so I can stretch him away, which is going to pull these points up here. It's going to pull them up. And these points down here on the other side, it's going to pull them down. Okay, so I can stretch them away from the x-axis. Okay, and how that graph's going to look, let's just look at a graph. If I want to stretch them, let's go a stretch 3 times farther. And stretches or shrinks are always times. They're always factors, a multiple. So that means I want to take each of these points and move them 3 times farther than where they are. So since this point's at 0, it's 0 from the x-axis, that stays put. This one is 1 unit away from the x-axis, so it's going to go 3 times farther. So 1 times 3 is 3, so it's going up 1, 2, 3, so it's going to be there. This one's 2, it needs to be 3 times farther, so it's going to be 6. So 2, 4, 6, so it's going to put it up here. Okay, it's the same, this point down here is down 1, it needs to go 3 times farther down now. So it's going to go down 1, 2, 3. This one's at 2, so it's going to go down 2, 4, then 6. And so now my new line is going to be steeper because I've stretched this guy out. Okay, now a shrink on the other hand, let's go a shrink by 1/2, because 1/2 is going to make it smaller. So you think if you multiply something by 3, okay, it's going to make it bigger. If you multiply by 1/2, it's going to make it smaller. So here I want to make all these points half as far. So this point here now is going to be half as far, so it needs to be right there. This point here needs to be half as far, so it's going to be at 1. Okay, this point up here at 4 needs to be half as far, so it's going to be at 2. Okay, so each point is going to be half as far. Okay, 4, that put it as 2. So then we would shrink it down and it looks like that. Okay, because all the points are shrinking down towards the axis. Okay, it's a shrink by 1/2. So how that shows up in an equation, a vertical stretch and shrink, just like a vertical translation, we added onto the end here. Remember, we added or subtracted onto the end. Okay, for a vertical stretch or shrink, we're going to multiply outside of the function. So we're going to take a times the function f of x. And that's going to give me a vertical stretch or shrink. Okay, but to determine whether it's a stretch or shrink, well, it determines what number it is. So if it's a whole number bigger than 1, so like here we used 3, 4, 5, 5.6, as long as it's a number bigger than 1, okay, then it will be a stretch. So this a, if a is bigger than 1, it's going to be a stretch. Okay, now if it's less than 1 or a fraction, if a is less than 1, oh, but also bigger than 0, it has to be positive, then it will be a shrink. Okay, so if the number is small, it's going to shrink it down. If the number is bigger than 1, okay, it's going to stretch it out. Again, stretching it up, stretching it down. Okay, so that's vertical. Okay, horizontal. Okay, horizontal, just like on the other one, horizontal is that left and right. And just like with a horizontal translation, slide it left and right, it's gonna work backwards. Okay, the big number, multiplying by a big number, is actually gonna shrink it. And multiplying by a small number is actually gonna stretch it. Okay, so it's going to work backwards. And since it's horizontal, and the y-axis is what's in the middle there, this is gonna stretch or shrink it away or towards the y-axis. Okay, so if we draw our parent in, okay, let's do just our plain parent. Okay, so if I want to shrink, let's go stretch. Stretch by 2. Stretch by a factor of 2. Okay, it's going to pull these points out now this direction 2 times as far. So this one's over 1, I need to now make it over 2. This one's over 2, it now needs to be over 4. This one's over 3, now needs to be twice as far, over 6. Okay, hey, this point down here is over 1, so now it needs to be over 2, twice as far. Okay, so it just goes, that x-coordinate is now being twice as far. So now my new line, when I do a horizontal stretch, is going to look like that. So there's a stretch by 2. Okay, so now if we're going to shrink, let's shrink by 1/3. So now it's going to bring the points in. So now this point is going to be now 1/3 of the way. This 3 is going to be 1/3 of the way at 1. Okay, if we go over and we had a 6, 4, okay, 1, 2, 3, 1, 2, 3. It's now going to make it in at 3. Okay, so it's shrinking those points in. So we end up getting something kind of like, if we had it all in right, something kind of like this. So it's pulling those points in towards that y-axis. Okay, so that's that shrink. Okay, so just like our horizontal translations where we added here inside of the function, a horizontal stretch or shrink is going to multiply inside of the function. So we'll have f of a times x. So it's multiplied there inside. And we talked about here it works backwards. I should make that a star, not an x. Okay, it works backwards. So unlike over here, where if a is bigger than 1, it's a stretch. If a is less than 1, it's a shrink. This is going to go backwards. Okay, if a is less than 1, bigger than 0, it's a stretch. And it's going to be a stretch by 1 over a. So meaning it's going to show up in the equation. It's going to show up in this equation as the reciprocal. Again, the reciprocal of 2 is 1/2. The reciprocal of 5 is 1/5. Okay, so it'll show up as the reciprocal. Okay, now if I want to do a shrink, this is if a is greater than 1, it's going to be a shrink by 1 over a. So here, it's just a plain old, over here with vertical, it is how, if it's a 5, it's a stretch by 5. If it's a shrink, if it's 1/3, it's a shrink by 1/3. Over here, it works backwards. Okay. All right, so let's go ahead and let's just do an example. I think that will probably help. Okay, so first one here. So here's our function. We need to graph. Let's graph our parent. Let's graph our parent with plenty of room over here. Okay, so here's our parent. It's right here. It's got a y-intercept of -1, a slope right there of 1, so it'd be 1 over 1. So y-intercept of -1, slope of 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So it's going to look like this. Okay, so now let's do this first part. We want to graph g of x, and g of x is equal to f. I'm going to write it down. Gx is equal to f 1/3 of x. So this 1/3 is inside. So since it's inside, that tells me it's going to be up here, horizontal. So I know it's going to be horizontal. So horizontal works backwards. So that number is small, so that tells me it's going to be a horizontal stretch because it works backwards. It's going to be a horizontal stretch by a factor of 3. So that means I need to stretch it horizontally. I need to pull it out 3 times as far. So I take, let's say, this point here. It's over 1. I need to now make it over 1, 2, 3 times as far. This one here, over 2. So that would be 2, 4, 6 as far. Okay, this is over 3, so that'd be 3, 6, 9 as far. And connect your dots. So there is my g of x. Don't forget to label your parent function f of x. Okay, next one. H of x is 3 times f of x. Okay, so h of x, 3 times f of x. So this 3 is outside, out front of the function, so that tells me it's going to be vertical. Vertical works how you think it is, so since it's bigger than 1, that's a bigger number, it's going to be a vertical stretch by 3. So hey, it's still a stretch by 3, just like our last one. These were both stretches by 3. But this one's stretched this way. This one I'm now stretching up and down. So this one needs a stretch up and down. So this point here is up 1. It needs to now be up 1, 2, 3. This point's up 2. It needs to be up 3 times that. So 2, 4, 6. Okay. This point here that's on the axis will stay there. Okay. We connect the dots. Why is... Oh, because that one's in the wrong spot. Oh. Okay. Ignore. Can I make that smaller? There we go. Ignore that one. Put it in the wrong spot. 1, 2, 3. It would go there. There. That's when my points weren't lining up. If your points aren't lining up, then you did something wrong. That's why it's always best to do at least 3 points. Okay, so this is my h of x. Then it says to describe the transformations of the graph, which we did. Our describing is right here, a horizontal stretch by 3 for g of x, and h of x is a vertical stretch by 3. Okay, next we're going to do one more. Okay, so first we need to graph our parent. So our parent is this guy right here. F of x equals x plus 2. So this one has a y-intercept of 2, a slope of 1. So there's my slope. So crosses the y-intercept of 2, up 1 over 1, up 1 over 1, up 1 over 1. So we've got this nice little positive sloped line right here. Let's label it as f of x. Okay, change colors. Okay, now this guy. So let's write that function down. G of x equals f of 4x. Okay, that 4 there is inside. So that tells me it's going to be horizontal. Horizontal, left and right. Horizontal works backwards. So since that's a 4, that's going to be a horizontal shrink by 1/4 because it works backwards. So I need to pull all my points in a 4th. So I want to say, okay, dividing something by 4, I want to find one that's over 4. Let's see. Well, I can take a half in by a 4th, divide it up into 4 equal pieces, so it's going to be right there. Okay, 4 and by a 4th, 1, 2, 3, 4, that would be 1 right there. This one's going to stay put. 2 would put me right there at a half. 4, yep, be right there. So there is my horizontal shrink. Again, it pulled all my points in towards the y-axis. Okay. Next one. Okay. Our function, I'm going to write the function down. H of x equals 1/4 f of x. So that 1/4 there is outside. Since it's outside, that tells me it's going to be vertical. And vertical works how you think it is, so that would be a vertical shrink by 1/4. Again, both of these are the same. They're both shrinks by 1/4. They're just different directions. This one's now vertical, so we're going to shrink it in. We're going to pull it into the x-axis. So I need to take the points and I need to take their distance from the x-axis and make it a 4th smaller. Okay, so let's see. I want to take one that's 4 away. 1, 2, 3, 4. There you go, because that one's easy to take a 4th. That would be 1 away. This one's 2 away, so it needs to be a fourth of that, so put it as a half. Okay, this one, since it's on the axis, that would stay there. Okay, this one looks at 2, so it'd be a fourth of the way, and we want to go 4, that would be 1. So it looks like our line's looking like, okay, right there. So it took all these points, those red points, and it shrunk them down towards the x-axis. So there's my h of x. And then it says to describe the transformation, we did. It's a horizontal shrink by 1/4. This one's a vertical shrink by 1/4. Okay. All right, practice. I want you to do page 152, 18 through 40 even. We've got one more little part, and then we're done with section 3.6.